Here we have a SAT math problem. Okay, let's go to the question. How does the graph of f of x equals to x positive 2 times x negative 4 compare with the graph of g of x equals to x square? Here, the function f of x is quadratic because when we multiply this x and x, I am getting x square. Since this function contains x square and this is the largest exponent we have for the variable x when we multiply these two binomials. So since f of x contains x square, it's a quadratic function. And g of x is also a quadratic function, but this is a parent function of quadratic. So here we compare the quadratic function f of x with the parent function of quadratic, that is g of x equals to x square. Okay, for that what we have to do is we have to write the function f of x in vertex form. That is, the vertex form is f of x equals to a times x negative h whole square positive k. So once we write the quadratic function f of x in vertex form, it has to be compared with the parent function of quadratic, that is g of x equal to x square. Then we can understand the transformations which have to be applied over here in the parent function to get the function f of x. So that's what we have in the answer choices. That is the transformations which we have to do in g of x to get the graph of the function f of x. Okay, how do you have to get the vertex form of the quadratic function f of x? So for that, let's consider the stuff we have here. The quadratic function f of x is given in factored form. That is, x positive 2 is one factor, x negative 2 is another factor. When I equate each factor to 0, I'll be able to get the two x-intercepts. That is, by equating the first factor to 0, I'm getting x equals to negative 2. So this is one of the x-intercepts. And now let me equate the second factor, x negative 4 to 0. I'm getting x equals to positive 4. Okay, here I got two x-intercepts. Now, to get the exponent of the vertex, I have to find the average of the two x-intercepts. Okay, now let me get the average of the two x-intercepts. Actually, this h represents the exponent of the vertex. To get the average of this negative 2 and 4, I have to add these two values and divide by 2. Negative 2 positive 4 equals to 2. 2 divided by 2 is just 1. Okay, here I got the x-coordinate of the vertex for the quadratic function f of x. Now to get the y-coordinate, the vertex, what I have to do is I have to plug in this x-coordinate 1 for x into the function f of x. Okay, let me do it. Then I'm getting f of 1 equals to 1 positive 2 times 1 negative 4. Then I'm getting 1 positive 2 is 3, 1 negative 4 is negative 3, then I'm getting negative 9. Okay, so this negative 9 is the y-coordinate of the vertex, that is the value of k. So now I got the vertex of the quadratic function f of x, that is 1 comma negative 9. Okay, now we can write the function f of x in vertex form, that is f of x equals to a times x negative h. For h, we have 1, x negative 1 whole square, positive k. But for k, we have negative 9, so we can write negative 9 over here. Then here, the vertex form of a quadratic function f of x is not completed because there is an unknown constant a over here. How do you have to get the value of this a over here? Actually, this a is the leading coefficient. To get the value of this leading coefficient a, so we have to get the leading term x square in this factor form of this quadratic function f of x. So to get the leading coefficient x square, we have to multiply this x and x. When I do so, I'm getting x square. What is the coefficient of x square? So that is the number in front of x square. Clearly, it's 1. So the coefficient of x square is 1. This is the leading coefficient. So this is the value of a over here. In factor form, we can plug in 1 for a over here. Okay, now what we have to do is we have to compare the parent function of quadratic, that is g of x equals to x square, with this f of x. In factor form, the value of a over here represents a vertical stretch or compression. Usually, when the value of a is between 0 and 1, we have to say this is a vertical compression. If the value of a is greater than 1, it's a vertical stretch. But if the value of a equals to 1, there is no vertical stretch or compression. In the given quadratic function f of x, since the value of a is 1, there is no vertical stretch or compression. Okay, now let's compare other parts. Here we have x square. But here we have x negative 1 the whole square. That is 1 is subtracted from x over here. Since 1 is subtracted from x, this represents horizontal translation of 1 unit to the right. In case 1 is added to x, we have to say that's also an horizontal translation, but it has to be done to the left. That is 1 unit to the left. Since 1 is subtracted from x, this is an horizontal translation of 1 unit to the right. Okay, let me write the stuff over here. 1 unit to the right. Okay, here to this x square, 9 is subtracted. That is, there is a negative 9 over here. This represents a vertical translation. Since it's a negative value, it's a vertical translation of 9 units down. Okay, let me write the stuff over here. 9 units down. So we have to do two transformations in the parent function of quadratic g of x. to get the graph of the function f of x. So the two transformations are 1 unit horizontal translation of 1 unit to the right, vertical translation of 9 units down. Now we have to go over the answer choices one by one and get the one where we find these two transformations. Okay, now let me go over the answer choice A. The graph of g of x is moved to the left. Even in this point, we can reject answer choice A because here we have an horizontal translation to the right, but here we have left, so we can reject answer choice A. And also in answer choice B, we have right 1 unit. This is correct. The first transformation is correct. Okay, now let's look at the second transformation, down 8 units. But here we got down 9 units. Since it's 8 units over here, we can reject answer choice B as well. Now let's go over the answer choice C. So here we have left, but in our working, we got the horizontal translation to the right. So we can reject answer choice C. Okay, now answer choice D, the graph of g of x is moved to the right 1 unit and down 9 units. So whatever transformations we got over here, the same stuff we have in answer choice D. Therefore, the correct answer choice for this question is D.